the International Barley Hub seminar series. This is the second in the series. I'm Ian Bingham, and I'm a crop physiologist at SIUC, and I'll be chairing this afternoon's session. If I could just make sure everybody's microphones are muted. I'm getting a little bit of feedback. That might be from my own microphone actually, but it's my great pleasure to introduce Dr. Sarah Kendall from ADAS. She's going to be giving the presentation this afternoon. This is based on some joint work she does with Peter Berry, but it's Sarah that's going to be delivering the presentation. Sarah joined ADAS as a crop physiologist in 2012 after completing a PhD at York University on the temperature regulation of seed dormancy. And her research at ADAS is focused on improving crop yields in a sustainable manner. And in particular, I think the focus of her research is to better understand barley physiology, crop nutrition, harness the benefits of precision farming technologies, and also increase our understanding of tolerance to pest damage. Now, like a lot of the research at ADAS, Sarah's focus is very much on the applied research and putting science into practice. And living on a mixed farming Nottinghamshire, she's ideally qualified to do that. So I've been fortunate enough to work with Sarah on a number of projects over the years, and she's always proved to be an excellent speaker. So no pressure this afternoon, Sarah. And I'm looking forward to hearing her presentation on what is a relatively recent initiative by ADAS, and that's the Yield Enhancement Network. So I'll leave Sarah to explain the purpose of the network, but I think it's been an exciting development in recent years. Now, Sarah will be speaking for about 40 minutes or so, and there'll be ample time for questions at the end of the presentation. So if you do have a question, I just ask you to hold on to it for a wee while. And then when we open up the Q&A session, maybe you can pop your question into the chat box, or you can unmute your microphone and ask it in person. And that way, it'll be easier to keep track of the questions. So I think that's all I need to say. So over to you, Sarah. Thank you.
Thanks a lot, Ian. I'll just share my screen now. Hopefully everyone can see that okay. I presume someone will shout up if you can't see what I'm talking about. Thanks a lot, Ian, for the introduction, and good afternoon, everyone. And thanks for joining us this afternoon. So I'd just like to start by thanking the International Barley Hub for giving me the opportunity to talk about the work that we've been doing through the YEN, or the Yield Enhancement Network, focusing on barley. And this really is an industry collaboration. And as Ian's explained, I work with Pete Berry at ADAS, leading the barley side of things on the YEN front. So before I get into the detail of the presentation, I just wanted to take a moment really to acknowledge and thank all the YEN sponsors, for which there are many, and you can see the logos of the sponsors on this slide here. The YEN really is an industry collaboration, and it wouldn't exist without the ongoing support of all the sponsors shown here. So what does the Yield Enhancement Network, or the YEN, really represent? So we're striving to achieve better than best practice. The YEN was initiated in 2012 with an initial focus on wheat, and it was set up to try and identify and to support arable innovators. Since then, the network has expanded to include multiple crop types, so oilseed rape, peas, beans, grass, and more recently, we've now got a new network that's focusing very much on crop nutrition, which we call YEN Nutrition. And the latest addition to the YEN family is YEN Zero, which is due to be launched at the start of June. Today, I'll be focusing on barley, but we'll use some examples from the work that we've done on wheat within the network to try and showcase what can be achieved. And at the end of the presentation, I'll also discuss yen nutrition, as we've got some interesting data showing the prevalence of nutrient deficiencies in spring barley. And I'll give yen 0 a quick mention too. So to start with, I'd just like to try and introduce and explain yen as a concept, really. So I said that the aim of the yen was to try and identify and support arable innovators. And we've really began all this with a network that's very focused on improving crop yields. But actually what we think we've got is a concept that you could apply to many different targets or areas of interest. The yen is really based around 4 important areas. So the first is concepts. So the way that we think about yield in the yen is very much based on the common concepts that are set out, for example, in the wheat and the barley growth guides. So it's about trying to start with a common concept that's based on science and understandings. The next kind of core element really is the metrics, and this is absolutely fundamental to the yen. So it's thinking about measurements, data and targets. And one of the ways in which we've really tried to bring metrics to life is through the benchmarking element of the yen. So you can see here in this diagram, we use this in our yen reports, whereby we're trying to present back growers' data, but allow them to understand it with, against other farmers' data as well. And I've already mentioned the reports that we use to also help to explain the many aspects of the measurements and the data that we collect. The third element is designs. So obviously the data and the information is really important, but actually what we want to do and what we're showing in this diagram here is we want to take that further. So from that understanding of what does the data mean, we want to try and encourage farmers and agronomists to then ask questions and come up with ideas as a consequence of that. And then finally, we've got the test element. So to bring this round to a full circle, actually what's really important here is that there is a way in which growers can understand whether, the consequence of these ideas. So we want people, and we want to be able to facilitate and help people to test the ideas that they've come up with. And one of the ways in which this has been supported through the yen is through farm innovation groups, and field labs would be another example of this, whereby farmers can carry out coordinated tests to add impact to what they're looking at. So really this is trying to enhance the confidence building and prototyping around those ideas. A really important aspect of the yen is that these are networks that are open to all: farmers, advisors, industry, academics and students. So we're wanting to work with everybody in this. And I think that's really important, and I think that in part has been why the yen has been quite successful. And it really is an example of farm-centric research. And just to say as well that to support the testing element of the yen, we have this guide to farmers' crop trials that's actually a really useful guide in helping people to understand how best to set up on-farm trials as well, which is available on the ADAS website. So I've already mentioned about the yen data, and actually what's really important here is that we're using this as a way to try and connect farming with physiology. So as a physiologist, I'm obviously really interested in all these aspects of data that's shown on the slide here that we're trying to bring together. But what we want to do is really show how this is of significant value to the farmers and agronomists that are involved in the yen. So yen entrants have opportunities to send in soil samples, leaf samples, a sample of the whole crop pre-harvest, as well as grain samples for analysis. And this obviously produces many, many different metrics. We then couple that with robust measurements of yield. And so this is usually using a weighbridge yield in most cases, along with agronomy information and weather data to produce a detailed picture of the crop and its growing environment. And I started by introducing the yen from a concept perspective. And this slide really represents our very simple concept for how we as physiologists think about yield. And clearly this is a huge simplification of you know, how we explain what the yield that people end up with. But from a conceptual point of view is really crucial to how we think about yield in the yen. So this is really simply the resources, so solar energy and water, and the availability of those resources to the crop, how well the crop captures those resources, and then how well those resources are then converted into biomass. And so we've used this concept as a simple way of trying to explain yield and think about it from the perspective of the light and water available to the crop. And what we're encouraging growers to think about is how can they maximize the amount of light and the amount of water that is captured by their crops, and to think about yield from that perspective. So I've mentioned yield. One of the really important things to point out about the yen is that we have a competition, but we don't just award prizes for the highest yields. So one of the things that we've developed in the yen is to create a yield potential model. And we then have a competition that looks at yield as a percentage of potential yield. This is actually really important because what it allows is for growers that are on different soil types that therefore have a different yield potential, for them to still be involved from a competitive perspective. So whilst you may not achieve the highest yield, you might actually achieve the highest percent of potential yield. So we use two different yield potential models, an autumn model and a spring model. And the development of the spring model is really a great example of how the yen as a network has adapted to different farmer demands. So we had a number of growers in Scotland who were interested in entering their spring barley crops into the yen, but really quite dissatisfied about the fact that they were being compared to winter crops and their yields were being calculated as a percent of potential for a winter or an autumn crop. So we kindly, Syngenta kindly provided some funding to develop a model for spring crops. And so in the slide here, you can see that we've got two estimations of yield potential. So what the yield potential model represents, and I'm going to try and just explain this quite simply, it represents a theoretically perfect variety that's planted in early February and harvested at the start of September. And we say that it's grown with inspired husbandry. And this is all important because it's important to clarify and get across the message that we're not trying to model yield, and we're not trying to come up with yield values that we expect farmers could go out and achieve today. So this is something, it's a target or it's something to look at, but really what it is it's a representation of the resources available. And if the crop was good at capturing those resources and good at converting those resources, these are the types of yields that could be achieved. And so in the map here, what you can see is the variation in potential yield. So we've got the autumn and the spring models. What's really important to highlight to start with is that these maps are generated on the basis that the soil texture is the same across the UK. So this is using a 200 millimetre of soil available water to come up with these the potential yields shown here. So it's using the weather that will be experienced at all of these different places, but it's standardizing the water available for the soil. When we calculate the potential yield for a particular entry, we're using, we calculate the soil available water from the grower's estimation of their soil texture. So they get a site-specific potential yield. And so what we're doing from a barley perspective is we're assuming that the crop in our model is capable of capturing 60% of annual light energy and converting it to 1.4 tonnes of biomass per terajoule. So that 1.4 tonnes of biomass, that resource use efficiency, so that's an improvement over what we would estimate crops are currently converting light into biomass. We're also assuming that 75% of the available water held in the soil to 1.5 metre depth is available, plus also the rainfall from February to August, and that's converted at a rate of each 18 millimetres of water being converted to 1 tonne of biomass. And we're assuming a harvest index of 60%. So if we look at the map here for the spring crop, you can see here down in Kent, we've got potential yields of over 10 tonnes per hectare. And then down in the southwest, some of these potential yields exceed 18 tonnes per hectare. So we've got a big variation in potential yield that really represents the difference in the amount of light and the amount of water that's available to the crop. So another important aspect of the data is how it's all interpreted and what it actually really means. And so we're reporting the data back to the growers and the agronomists involved in the yen through a report. So it's a 24-page report, and we report back over 100 explanatory metrics. And so we've now developed a specific spring barley report whereby the spring barley crops are just benchmarked against other spring barley crops. And for many growers involved in the yen, I think this is where the real value sits. So the competition part is, you know, it's a bit of fun. Actually, the value is all the information that's obtained about the crop. And it's allowing growers to start to try and understand how they can explain their yields and understanding about what limited the yield in their own situation. And I think the use of the yen report is a repetitive process. So it's the type of thing that we like to think that growers kind of go back to throughout the season and in years to come to try and look back at the data and understand what it meant, but also use the data as a foundation then for potentially making changes to a strategy going forward. So where has this got us from a wheat perspective? So we now have well over 1,000 yields in the cereal yen data set, and the majority of these are wheat. And we've been able to show through analysis of the data set that a yield of 15 tonnes per hectare is possible almost anywhere, as long as the soil can provide enough water. So that's really thinking about yield as in potential yield. We've seen that high yields are much less about what you spend and much more about attention to detail. And this is a really important message, and I'll come back to this when I mention Yen Zero at the end of the presentation as well. We've found an important farm factor, and I think this is something we really would love to be able to understand in more detail. So actually, it's those kind of farm credentials and the decision-making process that are really important in determining yields, and as I've mentioned, not just about how much money is spent on the crop. So through our analysis of the data set, we've been able to show that nutrient deficiencies appear to be common, and what we see is that large yields come from crops. So the high yielding wheat crops tend to have a large biomass, they have many ears, but from that perspective, they're risky crops which need careful management, especially in terms of fungicides and PGRs. And so these associations have prompted us to develop a concept of crop momentum, whereby management prevents the crop from being in a situation where growth is checked and minimises deficiencies. So I think because the wheat data set has accumulated a lot of yields, we've been able to do quite thorough analyses of the data set that whilst they can't show cause and effect, they can show associations, and it's allowed us to start to identify questions that really need more focus and more research to understand in more detail. So if I move on now to focus a bit on spring barley, so I've already mentioned that we were able to develop a yield potential model for spring barley, and we've also been able to report the data in a spring barley specific report to allow the growers that are entering spring barley crops to benchmark their crops with other spring barley crops. And I think that's been, for those involved, a valuable exercise. So across the 2 years in which we've estimated potential yields for spring barley and benchmarked them separately, we've had almost 50 entries. And whilst this is still a very small data set, and so we haven't been able to do a thorough analysis of the data yet, there is still lots of useful information which can help growers to understand the performance of their crop and the limitations of yield. So the graph here the figure here just shows where these crops have been located across the 2 seasons. And so in the table here, you can see some of the yield data. So in 2019, we had an average yield of 8.3 tonnes per hectare compared to the UK average of 6 tonnes per hectare, and a lower average in 2020 of 7.2 compared to the UK average of 5.8 tonnes per hectare. What's really important to look at is the range here in yields that's been achieved. And one thing I would really like to highlight is that whilst in yen we're interested in understanding how high yields can be achieved, actually there is a lot to learn for anybody, irrespective of the type of yield that you may achieve on your farm. So we really encourage growers to get involved with the yen, and you don't need to be someone that's achieving really high yields to get things out of the yen. And so you can see, particularly in 2020, we did actually have some low yielding crops involved in the yen. In terms of potential yield, we had an average potential yield. So remember, that's linked back to that map that I showed of the UK with the different potentials. And these ranged from 12.3 to 18.2 in 2019, with an average of 14.2 tonnes per hectare, and then ranged from 10.4 to 18.1 tonnes per hectare, with an average of 15 tonnes in 2020. When I'm making these comments about the differences between 2019 and 2020, it's just important to note that obviously in some cases these are different sites, so we're not comparing the same crops necessarily in two seasons, and hence there is quite a lot of variation between the 2 years. I mentioned that we think of yield not only as absolute yield, but also in this percent of potential yield context. And so you can see in 2019, we had an average of 59% of the potential yield achieved. And in 2020, it was a bit lower at just under 50% of the potential yield achieved. So I've talked a lot about kind of the key metrics and the data. And so I've compiled this table here just to show some of the things that we're particularly interested in understanding. And I've also got up here the Chagos Spring Barley Guide, which actually is a really, really useful resource. And from our perspective, when we've been thinking about the potential yield model for spring barley, and also about trying to provide benchmarks for key metrics, this guide and the data within the guide has been really useful for doing that. So in this table, I've summarised the mean values for 2019 and 2020 from the crops entered in the yen against the Chagos benchmarks. And so you can see that we had this mean yield of 8.3 in 2019 against a mean yield of 7.2 in 2020. And the benchmark in the Chagos guide is 8.3. Barley's a sink limited crop, and so the first place we're interested in looking at trying to explain and understand yield is looking at the number of grains per metre square, and then breaking that down to think about the number of ears per metre square and the number of grains per ear. And so you can see the benchmark values here in the Chagos Growth Barley Guide, with a benchmark of 872 ears per metre square with 21 grains per ear, giving just over 18,500 grains per metre square. And so it's interesting looking at the different dynamics between the different years in terms of how the different yields are composed. And one thing that stands out really is that we see the lower yield of 7.2 in 2020 and quite a substantial reduction in the number of grains per metre square compared to both the 2019 yen mean and also to the Chagos benchmark. Another interesting thing is looking at harvest index. So the Chagos benchmark would be 54%, and we saw a very similar value with the yen data set in 2020 and a lower value for harvest index for the 2019 data set. So what we're really trying to do, and this is obviously a very high level summary, is try and look at the yields and then try and break them down from a physiological perspective. And I'll go into a little bit more detail from that perspective now. So these figures here just show the relationships between yield in both 2019 and 2020. So that's indicated with the different coloured dots. against the components of yield. So the first figure, we've got yield, so ears per metre square against yield. And you can see that there is a trend for the increasing number of ears per metre square, kind of leading to a higher yield, but not a overly strong relationship. If we then compare the number of grains per ear with yield, you can see that the relationship is really very poor, and there is huge variation, and you know, very difficult to pick out any trend at all there. So that's in line with what we would expect in terms of the sink limitation. And then if we look at the correlation between grains per metre square and yield, you can see here that we've got an R squared of 0.69, so a good correlation really between these parameters. So this really kind of confirms what we know in terms of the sink limitation. But not all these crops behave the same. And I think I'm going to now talk about a couple of case studies that try and break things down in terms of trying to understand more about the limitations. So I am going to focus on the two winning crops in each year for this, but as I've already explained, the real value of the yen data set is having a big data set that's based on many crops grown in different places and in different environments and with a range of yields. So this slide really summarises lots of information. Sorry, it's a bit of a busy slide, about the winner of the spring barley category in 2019. So this was Alex Wilcox, who's based in Norfolk. And so this is an image of his crop, and the crop achieved a yield of 10.7 tonnes per hectare. And so this was 58% of the potential yield, and we estimated this to be 18.6 tonnes per hectare. The crop had a biomass of 13.9 tonnes per hectare, and we estimated that the soil available water was 375 millimetres, and there was 203 millimetres of rain, and this gave a total amount of water available of 591 millimetres. I should say that the rainfall there will have been March through to August, so it's not an annual rainfall. So there's just some details here about the agronomy that Alex used. So he's on a clay loam soil type. The crop was grown after wheat. It had regular pig manure, and it was sown really quite early on the 15th of January, and the variety was Laureate. And he applied 110 kilos of nitrogen in 2 applications. And on the left here, what you can see is the benchmarking figures that we use in the yen report. And so this is just a summary of some of those physiological measurements that we're interested in. So one thing that stands out really is that, and I hope you can see it here, so Alex's crop was composed of quite a modest number of ears, so under 800 ears per metre square, but actually it had a very high number of grains per ear, so 27 grains per ear. And this resulted in approximately 21,600 grains per metre square. And you can see here that the grain nitrogen was just over 1.8%. So obviously there's a balance between the number of ears per metre square and the number of grains per ear. And here we've got a kind of modest number of ears and a very high number of grains per ear. And so it's interesting to try and think about what the implication would have been if the crop had had a higher number of ears per metre square. So the crop was drilled early, and of course what we don't have an understanding of is the kind of dynamics of tillering. So was it that the number of shoots created was quite modest, or was there a high amount of tiller loss? But I think kind of focusing on understanding those dynamics in this crop could be a useful indication of trying to get to grips with the limitation. But nevertheless, 10.7 tonnes per hectare is obviously a very good yield to be achieving. And then the next example is David Bell's crop of Diablo that was the winning crop in 2020. And so David achieved a yield of 11.3 tonnes per hectare, which was a fantastic achievement. And this actually measured 83% of the potential yield, which was 13.7 tonnes per hectare. So the soil type was a sandy clay loam, but it was a shallow soil. And so that actually had a limit in terms of the potential yield that was calculated. Hence why this is, you know, getting towards one of the lower potential yields that's calculated. So where there's a shallow soil and rooting depth may be restricted, that obviously has an impact on the amount of water that's available to the crop. And you can see here that the amount of water was considerably less than the amount of water available to Alex's crop. So quite a difference there. Again, this crop was after wheat. It had cattle FYM applied, and it was sown on the 25th of March with 380 seeds per metre square. And it received 133 kilos of N per hectare in just one application. And what's interesting, if we just skip to looking at the grain nitrogen content, you can see that this came out at just under 1.5%. So a really good yield, well, a fantastic yield, and meeting the specification as well for malting. The makeup of David's crop was really quite the reverse of Alex's. So you can see in this chart at the top here, we've got the number of ears per metre square, and this was really quite high, so 1,095 ears per metre square, with then a more average number of grains per ear measuring at 18 grains per ear. You can see here that the harvest index was coming out just under 60%. So that's way above the benchmark of 54% and actually around the target of our yield potential model of 60%. So the question here is kind of, if a really high number of ears has been achieved, so you know, a lot of those tillers have been retained, is there anything that can be done to try and improve the number of grains per ear? And obviously that's really linked to photosynthesis, so making sure nothing is kind of lacking in terms of nutrition in the crop, and also making sure that the crop is as disease-free as possible to maximise photosynthesis at that time. So I'm going to move on now just to mention yen nutrition and very briefly some of the interesting results coming out of yen nutrition from a spring barley perspective. So as I mentioned, yen nutrition is a new-ish network. So we launched it last spring, and it's really focused on crop nutrition and mainly benchmarking grain nutrient data. And the aim of yen nutrition is to try and provide better monitoring to improve crop nutrition. So we're used to being advised to analyse soils every 3 to 5 years for pH, for pK and magnesium. And we can analyse for all 12 nutrients through leaf analysis to determine if the crop is running low in early spring. But most nutrients are taken up during periods of fast growth, so we're kind of always having to anticipate what the crop is going to do. But we've only just realised that if we analyse the crop at harvest, we have the ability to understand whether or not kind of the nutrition strategy was right or not for all 12 nutrients. And so we've been analysing nutrients in the grain for quite a few years, since 2016 in the yen. And grain analysis is now recommended, particularly for phosphorus in RB209 now. And so we're using yen nutrition as really a way of trying to learn much more about how we can use grain analysis to help inform better decision making from a crop nutrition perspective on farm. So again, yen nutrition is very focused on data and reporting data back to try and provide growers and agronomists with information that they can digest and interpret and hopefully then use to make informed decisions, or potentially also to kind of follow that circle around and come up with ideas and then test things. So change their strategy or test a product, but actually look at the impact of doing something different. So we have a number of different reports within yen nutrition. The first is an offtake report, which is really as soon as the grain samples have been analysed. The second is a benchmarking report, and so that's when most of the samples have been analysed, and we use these box and whisker plots, as you can see in the diagram here, to show where a particular grower's data or crop sits compared to everyone else's. We also use these charts, which we're calling target charts, to really try and bring the data to life a bit. And you can see an example of this here, where we're able to show kind of the critical levels, if we have a good understanding of what they are, which there's variation in the confidence in some of those critical thresholds for the different nutrients. And we're very kind of open about that and hope that there'll be a means for trying to improve our understanding of those. And also comparing to the average as well with these different charts. We then provide a season summary, which is when most of the data is being analysed and interpreted. And then we also have an annual review that's available to any stakeholder. And we have just published our first annual review. So if anyone listening would like to have a copy of that, you can email yen@adas.co.uk and we can send that to you. But this is a talk about barley, and so I just thought I would present a snapshot really of some of the data from yen nutrition. So the data I'm showing here is from 166 spring barley crops that were analysed as part of yen nutrition. And the pie chart here shows the number of nutrients that were deficient. So that's the first number. So we've got 1, 2, 3, or more than 3, or none. And then the proportion of crops with this number of deficiencies. So what this is showing is that 3% of the spring barley crops had no deficiencies. We had 43% of the crops with 1 deficiency, 46% of the crops with 2, and then just 7% of the crops with 3 deficiencies and 1% with more than 3. And I should highlight that we're focused here on the nutrients that are shown on this chart. So for some of the nutrients, we have no understanding of what the critical threshold or level could be that would indicate a deficiency. There's, as I've already mentioned, there's variation in our confidence in some of the thresholds for the nutrients that are shown here. And these are taken from a variety of sources, but all are from sources where they have been published. But I think this is interesting. So what we're able to show and what really stands out is the proportion of crops that have that show manganese deficiency. So you can see 90% of the crops that were analysed through yen nutrition were shown to be deficient in manganese. And then we've got more than 50% of the crops that were shown to be deficient in phosphorus. and then just less than 50 for nitrogen. Clearly for nitrogen, it's really important to highlight that some of these crops may have been aimed at malting with low grain N percentages. So whilst they're shown as deficient in this case, clearly the target may have been low grain nitrogen, in which case, from a grower's perspective, that was very much the target and what would be required. So I think there's lots of interesting questions that you could ask for this, and it really is starting to highlight areas that we should be focusing in on from a nutrition perspective. And so registration for Yen Nutrition will be available shortly on the Yen website. If anyone is interested in finding out more about what we're doing or registering crops, you can visit the website for more information on that. And then I just want to finish really with introducing, for those of you that might not have heard about what we're doing, Yen Zero. So this is a new member of the Yen family, which is launching in early June. And Yen Zero is really something that we've set up as a way of helping to support this journey towards net zero. So Yen Zero aims to bring together key players throughout the agricultural industry to try and identify strategies that reduce the environmental impact of farming. So the network will benchmark field greenhouse gas intensities for combinable crops, split into the different emission sources, and it's focused on the benchmarking. So it will also consider proposals for mitigation strategies as well. And it will also host discussion forums to address issues around achieving net zero. And so at the centre of this really is crop greenhouse gas intensity analysis that we did with funding from the Morley Agricultural Foundation, where we've used previous serial Yen entries to try and estimate the greenhouse gas intensities for those crops. And that will act as a foundational resource. And you can see that here in this graph, whereby we have each one of these bars here represents an individual greenhouse gas intensity for an individual crop. And then we've got the corresponding yield shown with these yellow dots here. You can see that there's large variation. So we've got some crops that have got greenhouse gas intensities of less than 200 kilos of CO2 per tonne. And then you can see it ranges to more than 400 kilos of CO2 per tonne. But this is interesting because obviously there's lots of questions around the cost of high yields from an environmental perspective. And what we can show here is that there is a trend for higher yielding crops to have the lower greenhouse gas intensities. And so we're hoping that together this will allow a better understanding of the factors driving variation in greenhouse gas emissions. So again, if you're interested to find out more about Yen Zero, please have a look on the Yen website. And then again, I just want to finish by acknowledging all the Yen sponsors again for their continued support. And if you would like to find out anything else about the Yen, you can contact us on email at yen@adas.co.uk, or there's lots of information on the Yen website. Thank you very much.
Thank you, Sarah. Very interesting. Excellent talk. Thank you. Well, I wasn't disappointed. Up to your usual standard. So this is now open for questions. I'm sure there'll be questions. So if you'd like to pop those into the chat, just to give you a few minutes to do that, I might just start by asking a question, Sarah. If that's all right.
Yeah, that's cool.
Do you get enough information on inputs? I was interested to see that the sort of number of fungicide applications was quite different between Alex Wilcox and David Bell. Do we have enough information coming in on that to be able to really probe the sort of sustainability questions?
Yeah, I mean, this has been a big challenge, kind of getting the balance right. And up until very recently, we were collecting data from growers by sending Excel spreadsheets and them filling in spreadsheets and sending it back to us. And it's all quite onerous. And we're now moving to try and collect data through a series of online forms, which probably from the grower's perspective doesn't really remove the onerous nature, but it does help us in terms of processing the data. There's a range really in terms of the information that we get back from growers. So we try and have a core set of questions that we kind of ask everybody to provide the information back on. And then we have another level that's optional. But fungicides is a really good example. So at kind of the broadest level, just knowing the number of fungicides that have been applied is very useful. And for example, for wheat, we've seen a significant association with the number of fungicides applied. But actually then there's another level where there's potential that you could start to actually understand more about the timings that the fungicide have been applied at, the products or the actives that have been used, and the rates that have been used. So I think, actually what makes this much more doable in terms of collecting lots of information is actually, if people could send their gatekeeper outputs, which obviously has all of this information. But at the moment, there's a lot of processing required to go from a PDF output from Gatekeeper to the information we need. So, but the more information that growers can provide, really it strengthens our data set.
Yeah, no, I agree. Thanks. Right, we've got some questions coming in. There's a question from JB. Excellent to see Yen Zero, it says Zen Zero, Yen Zero launch, but do you see future Yen schemes to include other areas of environmental interest, such as biodiversity?
Yeah, that's a really good question. I mean, I hope I kind of explained the Yen concept to almost allude to that, but we've enhanced yields. And really, what you could do is take our approach and apply it to any target that you're interested in. And so something like actually target being improving biodiversity, the concept really well. I think there's aspects of the with those kind of key four ideas being, concept, metric, the question, the tests, and the
Yeah, thanks, Sarah. I think you're breaking up a little bit, so I don't know whether that's just me or other folk are having that problem, but I think we got most of that. So a question from Julia South. It's a great program and obviously will get better as more growers join. How do you accommodate malting quality into the Yen, given that growing for malting won't always give the best yield? And how many spring barley growers in Yen are actually growing for malting?
Yeah, I hope you can hear me better now, Ian. Sorry if I'm breaking up.
Yes, it was just breaking up a little bit, but no, you carry on. You carry on.
Yeah, hi Julian, thanks for your question. I mean, the first thing to say is that this was driven by farmers who wanted this to really reflect malting quality parameters and not just yield. So from our perspective, there is real appetite to try and expand what we're doing on the barley front, to actually think about things from a quality perspective as well. And for wheat, we actually have a wheat quality award, which does focus in on those quality parameters for milling. So, I mean, my answer to that is that we're really open to looking at something that focuses on malting. And you're completely right that actually, you know, the highest yielding crop won't necessarily be the best crop from a malting perspective. Although I should add, you know, Dave's crop that yielded really well did go for malting as well. So that was a really great achievement. And we've got a mix. So in answer to your question around kind of have you got malting crops in there, we have got a mix. So there are some malting crops and there are some feed crops. So it's a mixed bag, really. Thank
you. And that's a very nice segue to our next question, which has come from Dave. So with the need for metrics to understand where potential yield comes from, why has this year's yen dropped soil microbial activity, which I assume would be a great indicator to soil health and in turn availability of nutrients to the growing crop?
Yeah, so what Dave's asking there is that we used to provide a soil health analysis from NRM that was quite a substantial cost. And so this year we reverted to a basic soil analysis for which we've had a substantial amount of feedback around the value of the soil health indicators that were provided as part of that report. So that we set out for it to be a way of obtaining feedback, but the feedback has very much been that was a part of the information that was really valued. So I suppose the answer, Dave, is that we're taking on board the feedback that we've got and are looking at ways in which we could try and incorporate those analyses in the future again.
Okay, thank you. A question here from George Laurie. How important is soil pH when you're assessing the yield potential?
Yeah, so I think the first thing to say is that clearly pH is important, and for soils the pH is, you know, greatly astray from where we would be looking for it to be from a target perspective. We're not suggesting that correcting that isn't important, but actually when we look at the association data set for all the different metrics that I've kind of talked about with yield, pH isn't something that comes out as we can say there is a significant association. And we see that there's other instances, so soil organic matter as well, for example, whereby we know it's important, but we can't show that through our analysis. And so I think what it means is in some cases, the crops or the kind of farms that we're working with are generally getting these things right, and so they're not limiting yield, and that's why it's hard to kind of show it through the type of analysis that we're doing.
Okay, and I think that. Sorry, go ahead.
Well, just can I just add as well, because I think maybe you're asking about yield potential, and so just to add to that, is that potential is it sounds complicated, but it's a very simple model, and of course what it actually doesn't take account of is all that actually also on you. So really the resources available, how they can be captured and converted, but deals many factors, you know, think about, for example, and we think that water in this case has always been beneficial, and as the you can definitely have too much of water the impact that has.
Yes, and I think that's led very nicely to the next question, which was from Robbie War, because he was asking about the simplicity, and is it too simplistic to estimate the yield potential just based on light and water? And if you were to layer additional factors on top of that, in a more complex model, I guess, what would they be in order of priority? What do you think the most important factors after light and water would be?
Yeah, I mean, this is something that growers pick up on all the time. For example, we're asked why crops in the southwest always have the highest yield potentials, and in practice they're not being achieved, and obviously our model doesn't account for disease. I think probably from my perspective, one of the challenges is thinking about the water that's available and the fact that our model takes no account of soil structure or compaction or other issues like that that clearly have a big impact on water availability and rooting depth.
I think if I would add my thoughts to that as well, I think the value of the model is to identify what as you say, the potential based on the sort of biophysical constraints at the time, and all these other factors like soil structure and disease. These are all management factors that basically remove and reduce the yield from that potential. So that really is probably something you don't want to model, because you don't want to try and explain the yield all the time. You want to say what the potential is, and then individuals look at their management to try and get to that potential, if I've understood it correctly.
Yeah, that's completely right. So if you could almost think of it, when the crop is sown, it has 100% of its potential, and then at every point going through the season, that potential then drops, or there's, we're knocking off potential each and all of the decisions that are being made. So yeah, I mean, you're completely right what you said, Ian. We're very much not trying to model yield, and we're trying to model, if you take all the constraints away, this is actually what your soil type and the depth of your soil with the weather that you incur, that's what your crop could be capable of achieving.
And I think there are also lessons to be learned by benchmarking against your near neighbours as well. So if there are a group of people submitting entries, from a region, for example, and you get a good idea then how close you are. You might be getting close to the potential as shown by the model, and even if the model is not that right, if you're coming out higher than other people in the same region, then you're doing something right. And equally, if you're not, then there are things that you might be able to improve on.
Yeah, and just on that kind of regional note, we've recently just finished an Innovate UK funded project that has actually allowed us to develop dynamic benchmarking, which at the moment is restricted to, half a dozen different metrics. But this is all on the YEN website, and it allows any person that's been involved in YEN in the past to log into the website, and then they can kind of constrain the data on a few different parameters, of which region is one, to then try and home in more on that benchmarking element and actually understand how their data compares on maybe a more relevant basis than just to all growers that were involved in a particular year.
Yeah, thanks. Another question from JB. What does Yen say about importance of variety choice, or is it relatively neutral if Yen growers are all using top elite wheat barley varieties from the RL?
Yeah, another good question. So we've looked at variety in a number of different ways when we've analysed, and we can't show significant associations. But I think this doesn't take away the importance of variety, and clearly choosing the right variety for your kind of growing conditions and choosing a variety based on traits that are important in that situation. It doesn't mean that that's not important. And I think, yeah, one of the things you may consider is that perhaps the growers that we're working with within Yen are all very good at choosing the right variety, and therefore it's difficult to pull that out when we're asking the question around how does variety associate with yield.
Yeah, thanks, Sarah. Well, that's come to the end of the questions, unless anybody's got any sort of further questions now. No, people's fingers have stopped clicking. Okay, well, if that's the case, then I would just like to thank you, on behalf of the International Barley Hub, Sarah, for giving up your time and giving us an excellent presentation and some great answers to questions. Thank you very much. And I think you've got another slide you're just going to pop up, haven't you?
Yeah, I'll just put that up now. See that now?
I can't see it. There we go. Right, and that is just to remind me to tell you all about the next seminar in the series, and that will be on the 22nd of June. So we're now moving to a sort of more monthly basis, and that will be given by Dr. Paul Gosling, who's at the AHDB, and he will be talking about the recommendation system. It's about barley varieties and the recommended list system. So it would be great to see you all there, and I would just like to add my thanks to you all for attending and for your really good questions. So thank you very much.
Thanks, Ian.